Welcome everyone to this explainer. If you're a technical architect or a developer, you're really going to want to pay attention today because we're diving into a massive industry shift. We're talking about the transition away from closed black box AI ecosystems toward highly modular, fully customizable frameworks. Specifically, we're going to break down what it takes to migrate over to DeepSeek Harness, or DSH, that open source agent framework that dropped in August 2026. If your team is currently running on something like Claude Code and you're wondering if it's finally time to own your own infrastructure, well, let's figure that out together. Okay, we've got a lot of ground to cover. We're going to look at the agent paradigm shift, how to prepare for the migration, adapting to Quartus architecture, operational and cost trade-offs, autonomous deployment, and finally, the migration verdict. Section 1. The agent paradigm shift. So to really understand why a migration to DSH even makes sense, we have to look at the philosophy behind it. When DeepSeek Harness launched, it grabbed over 24,000 GitHub stars on day one, and that is entirely because of its radical design. See, the industry has basically settled on this very clean formula. Model plus harness equals agent. The model itself is just the brain, right? It reasons, it understands intent, but on its own, it only outputs text. The harness is everything else. It's the memory, the tools, the file access, the UI. It is the nervous system. What DeepSeek did was introduce a framework built on the Quartus architecture, which is a programming paradigm for spatiotemporal composability. Now, in plain English, that just means everything is a plugin. It's got a privilege-free core, so the file system, the user interface, literally even the main agent orchestration loop itself, you can completely swap them out. And this brings us to the classic black box versus glass box dilemma. Look at Claude Code. It is a highly polished, incredibly mature product, but it's a fixed harness. It's a closed system that you just adopt and use. DeepSeek Harness is totally different. It's an MIT-licensed infrastructure kit that you actually own. It's kind of like comparing a pre-packaged consumer smartphone to a highly customizable Linux machine. With DSH, you get total glass-box transparency into exactly how the model is called, how the tools are chained together, and how tasks are actually orchestrated. Section 2. Preparing the migration. All right, so how do we practically move from that closed system into the glass box? Well, first off, your entire approach to prompt engineering is going to have to change. Let me give you a really fascinating example from some early DSH testing. Some developers were trying to build a 3D HTML environment of a Hobbiton birthday party from The Lord of the Rings. On their first try, they used a massive 17-word prompt. It had exact camera movements, lighting specs, object placements, and the result? Complete failure. The scene was broken and fragmented. But on the second try, they deleted all of those micromanaging constraints and just gave the model the end goal. They literally just said, build the 3D world of the Hobbiton birthday party based on the text. It worked perfectly on the very first attempt. The takeaway here is huge. The era of writing massive, restrictive prompts is over. We're moving from writing strict scripts to simply setting clear goals. So your actual migration journey looks like this. Step 1, port over and heavily trim down your system instructions. Stop trying to control every little step and just let the agent's reasoning take the wheel. Step 2, you're going to swap your fixed tool definitions into DSH plugins, because literally everything in DSH is a plugin that you configure with a simple YAML file or just an npm command. This part is incredibly straightforward. And step 3, implement session log state persistence. You'll move your context handling over to DeepSeek's traceable event stream. And of course, always follow this up with a solid validation procedure to make sure your new DSH setup is at least functionally matching, if not outperforming, your old cloud stock. Section 3. Adapting to Quartus architecture. Now, once your prompts and tools are migrated, you have to decide exactly how your agent is going to interact with its new environment. DSH doesn't just force you into one way of doing things. It actually ships with 4 distinct runtime modes. Standard mode is your daily driver. It gives you a full coding agent with shell and web access. Code mode is super interesting for orchestration. Instead of spitting out tool calls one by one, the model actually writes TypeScript to orchestrate its tool calls programmatically. This is absolutely perfect if you're building an autonomous, continuous queue processing agent. Then you've got minimal mode, which gives you a hyper-clean environment with just 2 tools, mostly for research and benchmarking. And finally, creator mode, which is a full inspection workshop for when you're developing your own custom plugins. You really get to dial in the execution mode to perfectly match your engineering needs. And here is where DSH completely changes the game for debugging. Every single session maintains an append-only log of everything the model sees. The system prompts, the tool results, all the context injections. It is essentially Git, but for agent trajectories. If your agent makes a bad decision and goes down the wrong path, you don't have to scrap the whole run and start over. You can literally fork the session right at the moment it messed up, rewind, and replay a totally different decision path. If you are running an autonomous queue processing agent, this gives you incredible error recovery and idiopotency. You have 100% auditability over every single move the agent makes.
Section 4. Operational and cost trade-offs.
Okay, transparency and modularity are great, but we need to talk about the reality of running this in production. Let's look at the hard numbers. In one real-world test, developers used DSH to build a real-time International Space Station tracker from scratch. The agent nailed the task. It was incredible. But over about 35 minutes and just 2 conversational turns, it burned through roughly 20 million tokens. It was processing at around 130 tokens per second. That is a massive operational token bill for a single app. Because it's an open infrastructure, it iterates constantly, and that can get very, very token hungry. But there is a massive silver lining here. By the end of that ISS tracker run, the DSH environment hit a 99% cache hit rate. To put that in perspective, that actually beats Claude Code's reported 98% for similar long context tasks. Because DeepSeek uses this incredible context caching on disk, that 99% hit rate drastically drives down the actual financial cost of burning those 20 million tokens. Because of this token burn dynamic, you really have to be smart about model routing. Early tests are showing that the DeepSeek V4 Flash model is going to give you way better ROI for your standard daily autonomous tasks. It's fast and it's cheap. The Pro model is obviously a huge jump in capability, but it costs a lot more. You want to reserve the Pro models strictly for complex, heavy reasoning architectural problems where you absolutely need that deep thinking power.
Section 5. Autonomous deployment architecture.
So how do we actually deploy this autonomously? Well, here is one of the absolute coolest parts of the Quartus plugin system. Migrating to DSH doesn't mean you are locked out of your old stack. DSH can function as the master orchestrator, and you can literally plug Claude, Code, or Codex right into it as subagent plugins. Say you have a specific queue item that Claude is just naturally better at handling. Your DSH agent can dequeue the work, realize Claude is the right tool for the job, delegate the task over to the Claude subagent, and then take the results back to report the status. It's brilliant. You get the ultimate flexibility to route work to whatever model is best for that exact moment. But listen, if you're building a fully autonomous, continuous queue processing agent, security has to be front and center. You must follow the safe use policy. You absolutely have to run this in dedicated virtual machines or highly isolated containers. Do not give it sensitive info. You need human-in-the-loop approval gates for any major database or system changes to prevent prompt injection disasters. Break your instructions into smaller, isolated steps, and please, only ever install reviewed, trusted plugins from the community. An autonomous agent with local machine access is incredibly powerful, so lock it down. Section 6, the final migration verdict. All right, we've gone through the paradigm shift, the prompt migration, the runtime modes, the costs, and the deployment. So what is the final verdict? Honestly, it entirely depends on what your engineering team values most. If you want a highly polished, zero-maintenance product where the vendor handles all the complexity for you, stay with Claude Code. But if you need a transparent, composable infrastructure layer, you should absolutely migrate to DeepSeek Harness. If you need that granular observability from the session logs, the power to swap out the core orchestration loop, and the freedom to route tasks between different models, even Claude itself, then DSH is going to give you some massive engineering advantages. I want to leave you with this one thought. By open sourcing the very infrastructure that makes an AI agent function, DeepSeek is effectively turning the agent harness into a free commodity. So if the harness is no longer a black box, what becomes the real competitive differentiator in your software engineering stack? Is it just the model, or is it how cleverly your team can orchestrate and customize these composable pieces? Thank you so much for joining me for this explainer. Keep experimenting, keep building, and I will catch you in the next one.